What if the sky above you suddenly exploded into rivers of green and red light, not as a rare miracle, but as a warning from the sun itself? Chapter 1. The day the sky caught fire. Imagine it's the evening of May 10th, 2024. People all over the world are heading outside for what they expect to be an ordinary night. Families are gathering for Mother's Day weekend. Some are at barbecues, some are at restaurants, others are simply relaxing at home. But within hours, the sky begins to change. Instead of its usual quiet darkness, the heavens start to shimmer. Strange curtains of green, red, and violet ripple overhead. For many, this is the first time they have ever seen the northern lights with their own eyes. People living in places like Arizona, France, Spain, and even as far south as Mexico look up in awe. Normally, auroras are confined to the far northern or southern latitudes, but not tonight. This time, the lights reach across the world. Social media lights up instantly. Instagram, TikTok, and Twitter are flooded with videos of glowing skies. Photos are shared from Nebraska, from Italy, from China. People call their friends and family outside. Look at the sky. You have to see this. For a moment, it feels like the whole planet is united by wonder. But while ordinary people are marveling at the beauty, scientists and engineers are watching the same event with tension. Because this isn't just a light show, it's the visible sign of something much bigger and far more dangerous. What the world is experiencing is the strongest solar storm in more than 3 decades. Later, it will be remembered by 2 names, the Mother's Day storm and the Gannon storm. A weekend like no other. From May 10th through May 13th, Earth was struck repeatedly by waves of charged particles thrown from the sun. It wasn't just a single flare or one sudden blast. Instead, the storm came in a series, almost like the sun had decided to open fire again and again. Each wave slammed into Earth's magnetic field, pushing it to the limit. The last time a storm of this intensity had hit was in 1989, when Quebec, Canada, suffered a massive power blackout after a geomagnetic disturbance collapsed part of the electrical grid. In 2024, no worldwide blackout happened, but the risks were real. Power companies were on high alert. Satellite operators were scrambling to protect equipment. Airline routes over the poles were changed to avoid radiation. Radio communications went dark in certain bands. And all of this was happening while millions of people were outside enjoying what seemed like a magical night. The birth of a name, so why is it called the Mother's Day storm? The answer is simple. The storm reached its most spectacular stage right on Mother's Day weekend. People associated the breathtaking auroras with that time, and the name stuck. But among scientists, another name emerged, the Gannon storm. It was named after Dr. Daniel Gannon, ANOAA, space weather scientist, who played a key role in tracking and explaining the storm to the public. Just like hurricanes are often named to give them an identity, this storm carried a human name that marked its place in history. Beauty and threat, the strange paradox of the Mother's Day storm is how it was received by the public versus how it was handled by experts. On one hand, the auroras were a gift. People in cities where northern lights had never been seen before could suddenly step outside and witness one of nature's most spectacular displays. It was a once-in-a-lifetime event. Some described it as the sky on fire or heaven opening. But for scientists, auroras are simply the visible signature of something dangerous. Earth being bombarded by charged particles from the sun. These particles collide with our magnetic field and atmosphere, releasing energy that we see as colored light. What looks like beauty is, in truth, Earth's shield struggling to hold the line. Every major aurora is a reminder that our planet is vulnerable. We are protected by Earth's magnetic field, but our modern technology is not so lucky. Power lines, satellites, communication systems, all of these are directly at risk during a geomagnetic storm. And in 2024, that risk was very real. A global event, the storm became a shared human experience unlike almost anything else in recent memory. In the United States, small towns were overrun with people driving to find darker skies to take photographs. In Europe, entire neighborhoods gathered outside, neighbors calling neighbors. In Asia, people from India to Japan were stunned as skies turned pink and purple. Even in cities with heavy light pollution, The glow of the auroras could sometimes cut through. People in Los Angeles, in Beijing, in Paris, all captured faint but unmistakable traces. The world's attention turned upward. For a few nights, Earth's billions of people looked at the same sky and saw the same lights. At the same time, news outlets rushed to explain what was happening. Space weather agencies released alerts. Scientists went on live interviews. Some outlets called it the strongest storm in modern times. Others simply labeled it historic. Awe, but also warning, and that's the strange duality of the Mother's Day storm. For ordinary people, it was beauty and awe. For scientists, it was a warning. This storm showed us just how dependent modern life is on invisible systems. The satellites that guide airplanes, the grids that power cities, the communications that tie the world together, all of them are vulnerable to a blast from the sun. And while May 2024 didn't bring catastrophe, it could have. Chapter 2. The Sun's Outburst. When we talk about the May 2024 solar storm, we're really talking about one of the most powerful natural outbursts our star has produced in decades. To understand why it was so extraordinary, we need to step back and see how storms on the sun actually form. They don't just appear out of nowhere. They are born out of a combination of sunspots, twisted magnetic fields, and the violent release of plasma called a coronal mass ejection, or CME. Think of the sun as a giant boiling ball of plasma, where gas and electricity flow together. Unlike Earth, which has a solid surface, the sun is a seething ocean of charged particles, constantly moving and shifting. At certain times, the surface of the sun develops dark patches we call sunspots. These look like bruises on the sun, but they are not scars. Instead, they are areas where magnetic fields are extremely concentrated, hundreds of times stronger than Earth's own magnetic field. When those fields twist and tangle, they sometimes snap. That snapping is called magnetic reconnection. It's one of the most powerful processes in the universe. When reconnection happens, magnetic energy is unleashed in the form of solar flares and CMEs. If you could watch it up close, it would look like invisible rubber bands stretched too far until they suddenly break, releasing all their energy in a single instant. A CME is the result of that energy release, a bubble of plasma and magnetic field hurled into space. These bubbles are massive, sometimes billions of tons of solar material traveling at speeds of millions of kilometers per hour. Imagine the sun twisting and snapping its own magnetic fields, then spitting out storms the size of planets. That's not exaggeration. The CME can engulf Earth in its path, distorting our planet's magnetic shield, and lighting up the skies with auroras as far south as Texas, Spain, or even Mexico. Now, solar storms like this are not random. They follow a rhythm, the solar cycle. About every 11 years, the sun goes from quiet to stormy and back again. During the peak of this cycle, sunspots multiply, and with them, the chance of storms increases. Scientists call this period solar maximum. Right now, we are living through solar cycle 25, which began in late 2019, and in May 2024, this cycle surged dramatically toward its peak. The sun unleashed not just one storm, but a series of them. In the span of a few days, multiple CMEs erupted, one after another, all heading toward Earth. Space weather forecasters described it as a cannonade, a relentless firing of plasma bullets from the sun's surface. Each CME alone could have been enough to create strong auroras, but together, they combined into something far greater. To picture this, think about ocean waves. A single wave can knock you down if it's strong enough, but when wave after wave crashes into shore, they build up, amplifying the energy. That is exactly what happened in May 2024. The Earth was bombarded by CME after CME, stacking up their effects, until the planet's magnetic shield was shaken to its limits. Scientists who tracked the storm described it as the most powerful since March 1989, the legendary geomagnetic storm that knocked out the power grid in Quebec, Canada, plunging millions into darkness for 9 hours. Back then, satellites tumbled out of control, and long-distance radio went silent. For decades, that 1989 storm stood as the benchmark for what the sun could do. In 2024, for the first time in a generation, we saw something that came close. The May storm was so strong that the KP index, the scale scientists use to measure geomagnetic activity, hit the maximum level of 9. That's the red zone, the equivalent of a hurricane on the Sun's storm scale. For context, most solar storms we experience on Earth hover around levels 4 or 5. Hitting 9 is rare and dangerous. What made this storm fascinating was how it lined up with history. The Sun has produced devastating events before. The Carrington event of 1859, the Quebec blackout of 1989, and now the Mother Day storm of 2024. Each of these storms teaches us something about our vulnerability and our resilience. In May, when those CMEs slammed into Earth, the skies erupted with colors people had never seen before. Residents in Northern Europe, Canada, and the Northern United States were used to auroras, but even they were astonished. What caught the world by surprise were the reports from much farther south. People in California, Texas, Spain, Italy, and even the Caribbean posted photos of shimmering red and purple skies. For some, it was the first aurora they had ever seen in their lives. The storm turned the entire planet into an audience for one of nature's grandest light shows. But beyond the beauty, the science of the storm revealed just how interconnected we are with the Sun. Every CME is a reminder that our planet is not isolated. We live inside the Sun's atmosphere, protected by our magnetic field, but vulnerable to its outbursts. When these storms strike, they test our technology, satellites, GPS, radio, power grids, and even airplanes flying at high altitudes. During the May storm, some satellites temporarily lost orientation, forcing operators to adjust them manually. Airlines rerouted certain flights away from the poles to avoid radio blackouts. Power companies monitored their systems closely, bracing for surges that could damage transformers. While we avoided a repeat of 1989's blackout, the storm was a warning shot. It showed us how fragile our technology can be when the Sun grows restless. Chapter 3, Earth Under Fire. When a solar storm leaves the Sun and races toward Earth, the real drama begins. Space, as vast and empty as it seems, is full of invisible shields and forces that protect our planet. One of the most important of these is Earth's magnetic field. It surrounds us like a giant bubble, invisible to our eyes but powerful enough to deflect most of the high-energy particles constantly streaming from the Sun. But during a solar storm, when billions of tons of charged plasma come crashing into this magnetic shield, the balance is shaken. That's when the Earth finds itself under fire. Let's start with the basics. Earth's magnetic field is like a great, invisible force field. It stretches far out into space, shaped a little like a comet with a long tail that trails away from the Sun. Most of the time, it quietly shields us from the solar wind, a constant breeze of particles blowing outward from the Sun. But when a storm arrives, that calm breeze turns into a hurricane. The incoming plasma slams into our magnetic bubble, compressing it on the Sun-facing side and stretching it farther out into space on the far side. Imagine pushing against a balloon with your hand. The shape warps and bends under pressure. That's essentially what happens to our magnetic field. And when the Sun's storm is strong enough, energy gets transferred into the magnetosphere, the region of space controlled by Earth's magnetic field. Magnetic lines twist, snap, and reconnect. Particles are funneled down into Earth's upper atmosphere near the poles. This is where one of the most breathtaking natural spectacles on Earth is born. The aurora. Auroras are one of the beautiful side effects of these otherwise dangerous storms. When charged particles from the Sun strike atoms of oxygen and nitrogen high in the atmosphere, they make those atoms glow. Oxygen produces the familiar green curtains of light, sometimes blending into red. Nitrogen adds shades of blue and violet. To the human eye, these lights ripple and dance, covering the sky with shifting, glowing veils. It is as though the Earth itself is alive, responding to the storm in a display of color and motion. During the May 2024 Mother's Day storm, people across the world witnessed auroras at latitudes that almost never see them. In the United States, states like Texas, Arizona, and Alabama reported glowing skies. In Europe, lights spread deep into southern regions. Social media filled with images of green and purple skies over cities where people had never expected to see such a phenomenon. For many, it was a once-in-a-lifetime experience. The sense of wonder was palpable. Families gathered outside, children pointed up in awe, and people described the experience as magical, even spiritual. But while the skies dazzled, hidden dangers were unfolding quietly in the background. Auroras are the visible face of a much larger, more complex process. The same energies that paint the sky can also disrupt technology that modern civilization depends on. Take satellites, for example. High-energy particles can interfere with electronics in orbit. During the May 2024 storm, several satellites had to be placed into safe mode to avoid damage. This means operators intentionally shut down non-essential systems and reduced activity to protect sensitive instruments from electrical overload. In some cases, satellites lost communication temporarily. It may sound like a minor inconvenience, but remember, satellites are responsible for GPS navigation, weather monitoring, communications, and even parts of our financial networks. A serious outage could ripple through daily life in ways most people never realize. Aviation also felt the storm's impact. At high altitudes near the poles, radiation levels rise during geomagnetic storms. Airlines rerouted long-haul flights to avoid polar routes, choosing longer but safer paths. Pilots and passengers may not have noticed much more than a slightly extended flight time, but behind the scenes, it was a clear reminder that cosmic events can reach directly into our air travel system. Then there are power grids. Back in 1989, a powerful solar storm famously knocked out electricity in Quebec, Canada, leaving millions in the dark for hours. Engineers learned hard lessons from that event, and today grids are better prepared. Still, they remain vulnerable. When charged particles from the sun stream into Earth's magnetic field, they induce electric currents in the ground. Those currents can overload transformers and other critical equipment. In May 2024, no major blackouts were reported, but there were alerts across North America and Europe. Utility companies monitored the situation closely, ready to act if voltage fluctuations became too severe. Another vulnerable system is shortwave radio. These radio frequencies, used by ships, planes, and emergency services, can be disrupted when solar storms ionize the upper atmosphere. And indeed, during the May 2024 storm, reports came in of shortwave blackouts across Asia, Africa, and the Americas. For hours at a time, communications were unreliable or silent. For amateur radio operators, the passionate hobbyists who track solar storms as closely as scientists, it was both frustrating and thrilling. They were witnessing firsthand the scale of the sun's power. Chapter 4. Echoes of History. When the Mother's Day storm of May 2024 lit up the skies, many people reached for their phones, pointed their cameras upward, and marveled at auroras dancing across places where they almost never appear. Social media filled with images of green, red, and purple curtains stretching across the horizon. But this was not the first time humanity had stood in awe of the sun's sudden outbursts. To understand the true weight of May 2024, we need to look back into history, where solar storms have left their mark sometimes as beautiful memories, sometimes as serious warnings. The Carrington event of 1859. The most famous storm in recorded history is what scientists call the Carrington event. In late August 1859, a British astronomer named Richard Carrington was watching the sun through his telescope. What he saw looked almost unreal. Two bright spots flashing across the solar surface. There were solar flares, bursts of light and energy caused by the sun's tangled magnetic fields breaking apart. Within hours, Earth felt the impact. The storm slammed into our planet's magnetic field with incredible force. Telegraph systems, the lifeline of communication at the time, went wild. In some places, telegraph operators reported sparks leaping from their equipment. Paper caught fire. Shocked workers unplugged batteries, but messages kept sending themselves through the lines, powered only by the storm's energy. Auroras appeared far closer to the equator than usual, glowing in places like Cuba and Hawaii. Imagine being a farmer in the 19th century, stepping outside at night and seeing the skies on fire with colors you had never imagined. Many thought the world was ending. The Carrington event taught humanity a new lesson. The the sun could reach across 93 million miles and shake the very foundation of our technology. At the time, technology meant telegraphs. Today, it means satellites, the internet, power grids, and aviation. The Quebec blackout of 1989. Fast forward more than a century. By March 1989, our world was far more electrified and interconnected than in Carrington's time. Quebec, Canada, relied heavily on high-voltage power lines to distribute electricity. That month, a powerful solar storm arrived. The storm's geomagnetic surge pushed currents into the ground, where they flowed into the electrical grid. At 2:44 a.m., the grid collapsed. In less than 2 minutes, Quebec was plunged into darkness. 6 million people were left without power for 9 hours. It was not just Quebec that felt the effects. Across North America, satellites malfunctioned, and some radio signals failed. In space, operators worried about damage to instruments. This blackout was a warning that modern life, with its deep dependence on electricity, was highly vulnerable. The storm did not destroy cities, but it showed how fragile even advanced infrastructure could be under the sun's pressure. Awe and danger. What connects Carrington in 1859, Quebec in 1989, and May 2024 is the paradox of solar storms. They inspire wonder and fear at the same time. When people look up at auroras, they often see only beauty, the shimmering colors, the dance of lights, the connection to nature. But beneath the spectacle lies danger, hidden in the invisible currents racing through our atmosphere and electrical systems. This paradox is not new. In fact, ancient cultures had their own ways of interpreting the same sights. For them, the night sky was a canvas of meaning, where natural events were messages from the divine. Myths and beliefs in Norse mythology, auroras were thought to be reflections from the shields of the Valkyries, warrior maidens guiding the souls of the dead to Valhalla. The lights were a reminder that battles and destiny were tied to the heavens. In Native American traditions, interpretations varied. Some tribes saw auroras as the spirits of ancestors dancing in the night sky. Others believed they were fires lit by powerful beings to signal warnings. In ancient China, red auroras were often seen as omens. Court astronomers sometimes linked them to unrest or changes in leadership. A sky glowing blood red was not just weather, it was a message. These beliefs show us how deeply auroras touched the human imagination. Without modern science, people used myth and story to explain what they saw. And in a way, those interpretations still capture the same truth we feel today, that auroras are both beautiful and unsettling, a reminder of forces larger than ourselves. Returning to May 2024. Now, think about the auroras of May 2020 for the Mother's Day storm. Photos from Arizona, Texas, Spain, and Italy went viral. For millions, it was their first time seeing the northern lights, and it felt like a gift. Families gathered in backyards, people drove into the countryside, and countless children will remember looking up and seeing the sky come alive. But behind the celebration, risks quietly unfolded. Airlines had to reroute flights near the poles. Satellites were pushed into safe mode. Some radio networks went silent. Engineers stayed alert, watching power grids for signs of overload. This duality, the joy of beauty and the seriousness of risk, is exactly what connects May 2024 to the storms of history. It was another reminder that the sun's storms are not just rare shows of light. They are part of an ongoing story between Earth and its star. A pattern across centuries. Looking at history, one truth becomes clear. Solar storms are not random surprises. They follow cycles, tied to the sun's own rhythm. The Carrington event happened during a strong cycle in the 19th century. The Quebec blackout arrived near a solar peak in the late 20th century. And May 2024 unfolded as solar cycle 25 surged toward its maximum. Chapter 5. What the future holds. The auroras of May 2024 left behind breathtaking photographs, news headlines, and social media memories. Yet when the lights faded, scientists quickly reminded the world of an uncomfortable truth. The sun is not finished. The storm was only one chapter in a much longer cycle. Our star is still building toward the peak of solar cycle 25, expected between 2024 and 2025. That means more storms, more auroras, and possibly more risks. the sun's ongoing rhythm. The sun is not a steady, calm sphere. It moves through rhythms, known as solar cycles, lasting about 11 years. During the quiet phase, sunspots are rare, and solar storms are less common. But at the peak, the sun's surface becomes restless, sunspots multiply. Magnetic fields twist and snap, and eruptions become more likely. Solar cycle 25 began in 2019. At first, scientists expected it to be average, or even weaker than previous cycles. But the events of 2023 and 2024 surprised many experts. Sunspots appeared faster than expected, and flares erupted more often. By the time of the May 2024 geomagnetic storm, researchers realized that this cycle could rival some of the strongest in living memory. If history is a guide, the most powerful storms often cluster around the cycle's peak. In other words, what we saw in May 2024 may not be the climax, it could be a warning shot. Scientists' warnings. Experts in space weather do not speak lightly. For decades, they have studied past events like the Carrington event of 1859 and the Quebec blackout of 1989. Their models show that storms of similar or greater intensity are still possible. A report from the U.S. National Academy of Sciences once described a modern Carrington-level storm as a low-frequency, high-impact disaster. That means it may not happen often, but if it does, the damage could ripple across every aspect of modern life. Satellites, GPS navigation, internet cables, financial networks, even the timing systems that run power plants, all could be disrupted. Some researchers estimate that recovery from such an event could take months or even years, depending on how severely infrastructure is hit. The May 2024 storm was powerful, but it was not catastrophic. It was strong enough to disrupt high-frequency radio, push satellites into safe mode, and light up skies far beyond the Arctic. But it stopped short of causing global blackouts. Scientists warned that this was more luck than certainty. A slightly stronger or more directly aimed storm could have tested our systems in ways we are not prepared for. Protecting Earth. So, what can humanity do in the face of such cosmic power? We cannot control the sun, but we can prepare. And in recent decades, efforts have quietly grown across the world. 1. Space weather forecasting. Just as meteorologists forecast storms on Earth, agencies like NASA, NOAA, and the European Space Agency monitor space weather. Satellites, such as the Solar and Heliospheric Observatory SOHO, and the Deep Space Climate Observatory DSCOV, sit between Earth and the Sun, measuring solar wind and magnetic fields. These spacecraft provide precious minutes to hours of warning before a storm hits. In May 2024, these alerts gave grid operators and airlines time to act. Pilots rerouted flights to avoid polar regions, where radiation can spike. Power companies adjusted loads to reduce stress on vulnerable equipment. The storm still caused disruptions, but without forecasting, the impact could have been far worse. 2. Hardening satellites. Modern life depends on satellites for communication, navigation, and observation. Engineers are now designing satellites with better shielding, redundant circuits, and recovery protocols. The goal is to ensure that even if a storm forces a satellite offline, it can reboot safely. 3. Preparing power grids. The backbone of civilization. The electrical grids among the most vulnerable systems. Utilities are exploring new methods to resist geomagnetically induced currents, which surge through long transmission lines during solar storms. Solutions include installing resistors, upgrading transformers, and creating rapid response systems that can isolate damage before it spreads. Some countries are investing heavily in these protections. Others lag behind, raising concerns about unequal resilience across the globe. In a world where economies and communications are tightly linked, one region's blackout can ripple across continents. The big question: are we ready? With every new aurora display, a question grows louder. Are we ready for a modern Carrington event? The honest answer is complicated. In some areas, yes, we have better forecasting tools, faster communication, and stronger awareness than in the past. But in other ways, no, we are far more dependent on vulnerable technology than people in 1859 or even 1989. Consider how many aspects of daily life rely on electricity and satellites. Navigation apps on smartphones, credit card transactions, global shipping routes, air traffic control, weather forecasting, and even agriculture all lean on systems that space weather can disturb. If a true superstorm struck, it would not just be an inconvenience, it could be a shock to modern civilization. Yet scientists emphasize that preparation, awareness, and investment can make the difference between temporary disruption and long-term disaster. The May 2024 storm was a real-world drill, a reminder that the cosmos still tests us. A bond of beauty and danger. Did you see the auroras during the Mother's Day storm? Share your experience in the comments. And if you want to keep exploring mysteries of the sun and beyond, consider liking this video and subscribing for more.